There are four different types of centers of a triangle that we're going to look at. First, there's the circumcenter, which is formed by drawing all the perpendicular bisectors of each side. Those three perpendicular bisectors will intersect at one point, and that one point is called the circumcenter, and it is the same distance from all of the vertices. So you could draw a circle that would circumscribe a triangle using the circumcenter as the center. There's also the orthocenter, which is where all three altitudes intersect. An interesting thing about the orthocenter is if you take the triangle, any of the triangles that are formed using one of the side lengths and the orthocenter, then the point of the triangle of the original triangle that you did not use would be the orthocenter of our new smaller triangle. So for example, P is the orthocenter of triangle ABC, but B, as in boy, is the orthocenter of triangle APC. If you were to extend the side to draw the altitude, the height, for all of them, they would intersect at point B. So the orthocenter is formed by drawing the altitudes. If you draw all the angle bisectors for each of the three angles of the triangle, they will intersect at one point called the incenter. The incenter is the center of the triangle for which you could draw a circle that fits perfectly inside the triangle. And if you draw all three medians of the triangle, you'll get what is called the centroid. The centroid has this interesting property where the centroid splits each median into a short segment and a longer segment. The short segment is half the length of the longer side for all the medians. So it splits it into thirds, 2/3 for the long side, 1/3 for the short side. Or if you know the long side, the short side's half of it. And you get the centroid by drawing the medians. The centroid is also the center of gravity of the triangle. If this triangle was rather than just a drawing, if it was an actual physical triangle made out of cardboard or something like that, the centroid would be the balancing point. It's the center of gravity. You could construct each of these using a compass, because you can make perpendicular bisectors from each vertex by taking your compass, stretching it out from each vertex, making a mark above and below. Switch vertices with that same length, mark above and below. Connect those X's formed, and that's the perpendicular bisector. Do that 3 times, you get the circumcenter. You can construct the angle bisectors, if you recall, by stretching your compass out from the vertex, marking off an equal distance on each of the sides of your triangle. Then, without changing the width of your compass, go out to where you marked and mark out again further. Make an arc from each point of intersection, create an X where those 2 arcs intersect, and then the line that goes from the vertex through that X is the angle bisector. You can construct the centroid by finding all of the midpoints. To find the midpoint, you do the same thing that you do for perpendicular bisector, except you don't draw the line through both of them, you just find where that line intersects, because that would be the midpoint. So then you use a straight edge draw from the vertex to the midpoint. And you can construct the orthocenter, the altitudes, by going from the vertex, measure out a distance further than it is to the opposite side, make 2 arcs on the opposite side, then from those 2 marks that you made, do what you did for the perpendicular bisector, using those 2 marks as your endpoints. But the first step is go from the vertex all the way across and measure out a distance, marking the 2 arcs where they intersect the opposite side, because those points will be the same distance away, so you see to the perpendicular bisector of that segment. So here's just a quick summary of the 4 centers. The circumcenter is the perpendicular bisectors. It's the center for a circumscribed circle. The orthocenter is where the altitudes intersect, and it forms an orthocentric set with the vertices. That's just the orthocentric set just means that the 4 points, no matter which triangle you take, the other point is the orthocenter for that triangle, like we discussed on the previous slide. The incenter is formed by constructing all of the angle bisectors, and it's the center for an inscribed circle. And then the centroid is the intersection of all of the medians, and that is the center of gravity. If you were to construct all of these centers on the same triangle, you would notice something pretty interesting, and that is that the circumcenter, the orthocenter, and the centroid are collinear, meaning there's one line. They're all in the same line. You can draw one line that contains all 3 of those points. That line is named after the mathematician that found that property. His name is Leonhard Euler. E-U-L-E-R, Euler. So that's the Euler line. Also, I'd recommend that you take a look at that in particular for some special triangles, like a right triangle. See where those centers fall. Also, for special cases, look for right triangles isosceles triangles, perhaps even a right isosceles triangle, and also for equilateral. Since this is some special triangles, there might be some special properties that you could look at by constructing the four centers.